Hello, Com217. Today we're going to be talking to you about the basics of cancer genetics. To give some background, let's talk about proto-oncogenes. These are genes that help cells grow. Think about a cell as a car. To function, you have to control how fast it goes. Proto-oncogenes function as the gas pedal to help cells grow and divide. But when they're mutated, they're known as oncogenes. They act as a stuck gas pedal, and they make cells divide and grow out of control.
Tumor suppressor genes are genes that slow down cell division and functions. They act like the brakes of a car, controlling cell division so cells don't divide too fast. When there is a mutation, these cells are turned off and cell division can get out of control. This can lead to cancer.
First, we will talk about TP53, a highly studied gene that is nicknamed the guardian of the genome. TP53 is mutated up to 50% of cancers, which is partly why scientists have made it the most researched gene. TP53 is a tumor suppressor gene, and when it is mutated, it can make it easier for people to get cancer. TP53 works to prevent tumors by stopping cells from dividing if there is DNA damage in the cell. An example would be UV light from the sun. UV rays can hit your skin cells and create significant DNA damage. This is why you should always wear sunscreen. Once the DNA in the cell is damaged, TP53 will tell the cell to go through programmed cell death. This prevents damaged DNA from accumulating in the cell, further stopping tumor formation and preventing cancer.
Next, we will cover breast cancer genes 1 and 2. These are the best known tumor suppressor genes linked to breast and ovarian cancer. BRCA1 interacts with several other proteins to mend double-stranded breaks in DNA. These breaks can be caused by radiation or other environmental exposures. BRCA1 is not alone in its efforts to protect our genetic material. BRCA2 is involved in DNA mismatch repair. It repairs damaged DNA with incorrect base pairs or destroys cells if the DNA cannot be fixed. These proteins play a role in ensuring the stability of our genetic material, preventing potentially dangerous gene rearrangements that can lead to cancer. A harmful BRCA mutation can be inherited from a parent. Each child of a parent who carries a mutation in these genes has a 50% chance of developing a risk for cancer. But BRCA mutations are very rare in the general population. In the US, about 1 in 400 people have this mutation.
The next tumor suppressor gene that we will talk about is Notchone. Notchone has many functions, but according to the National Center for Biotechnology, its main function is to aid in cell-to-cell communication. Notchone acts almost like a cellular telephone, giving cells a way to talk to one another and to let surrounding cells know where they are located. According to a 2011 paper in the Journal of Experimental Medicine by Lobry et al., scientists are still unsure about Notchone's overall cancer-causing mechanism, but it is known to play a key role in leukemias and skin cancers, specifically TALL and squamous cell carcinoma. Notchone has so many functions in cells that it is considered an oncogene and a tumor suppressor gene, meaning that it can cause cancer if it is expressed too much or can cause cancer if it is turned off. Notch genes are also highly conserved within different species, meaning they play an extremely important role in the growth of cells, as only genes vital for cell growth are passed on through evolution.
TP53, BRCA1, BRCA2, and Notchone aren't the only genes that work hard in our body to keep us healthy. There are many tumor suppressor genes and proto-oncogenes that all have unique and complex functions and seamlessly work together to prevent cancer. It's truly amazing how something so small can make such a big difference. So next time you look in the mirror, make sure that you thank your tumor suppressor genes and proto-oncogenes for keeping you healthy. Thanks for watching!